Welcome to Chapter 14 of Mastering ArcGIS by Maribeth Price. This PowerPoint is from the 5th edition, that's a 5th edition, which was designed to be used with ArcGIS 10.0 SP3, which we will be using in class. Again, this chapter is all about geodatabases, and it will help get us started for using geodatabases throughout GIS 3.12 and 3.14. A geodatabase is designed to store feature classes for a particular geographic area. It incorporates all feature classes, rasters, and tables in a single entity. It also stores rasters. There are three types of geodatabases. We will only be using a file geodatabase. Personal geodatabases are being phased out, and we do not yet have the option to use Oracle or SQL servers or other relational database management system databases. So we'll be using a file geodatabase, which is stored in folders. You may never open the folders, and if you do, you will immediately corrupt your database. They are for single users and small to large work groups. They have a 1 terabyte size limit, and they are cross-platform operable, meaning they work with Windows, Unix, and Linux. What goes into geodatabases? Feature classes, feature datasets, which are collections of related feature classes. You can think of feature classes as shapefiles. They work similarly to shapefiles, but they offer a whole lot more. You may put tables, annotation, relationships, planar topology classes, network topology classes, and also raster files in geodatabases. You may want to pause this slide and read the light blue information stringing over from the left side listing from ArcCatalog. I will not stop and read it for you, but you can pause and read some of the information to get you more familiar with geodatabases. You may also want to come back to this slide after watching the entire slideshow to review and find some of the items that I discussed throughout the PowerPoint presentation. Functional applications. Geodatabases support a variety of data management functions to enhance work, such as domains and subtypes, planar topology and spatial rules, network topology and connectivity rules, relationship classes for referential joins, and versioned editing in SDE geodatabases. First, let's talk about domains. A domain is a rule that determines the values that may be entered into an attribute. The rules are about what can go into the attribute fields. It reduces data entry and consistency errors. There are two of these domains that we're going to talk about: coded domains and range domains. Coded domains set a list of allowable values, such as a code being 1, 3, 6, and 12, that stands for 1 inch, 3 inch, 6 inch, and 12 inch pipe. Range domains set a range of allowable values. For example, a percentage being 0 to 100. Somebody would not be allowed to enter a value of 101% or a negative number in this domain. Subtypes. Subtypes are different categories created for a feature class, with each category having its own symbol and default values. Integer-coded classes of features automatically display with different symbols. They behave as different layers during editing. Each subtype can have its own default values, and this streamlines the attribute entry. Planar topology. We set up rules within and between layers that they must not overlap, must not have gaps, and they must not self-intersect. We use this during editing to ensure topologic consistency between features and feature classes. In the image on the right, we're trying to align county, state, and reservation boundaries. All of these should have the same boundary. There should not be 3 different boundary lines, particularly in this area and in this area. A definition for planar topology is an association of feature classes in a feature dataset, established by rules regarding the spatial relationships between the features, such as not overlapping each other. A network topology, also known as a network, is an association of linear edges and connecting points used to model the flow of a commodity, such as traffic or utilities. Connectivity rules, for example, can be set up so that a 12-inch pipe connects to a 6-inch pipe only through an adapter. On the left, we have a find path use of network topology, and on the right, we have a trace downstream use of network topology. Version editing only works with SDE geodatabases, so we're going to skip this at this point. A schema. A schema is a full description of all the feature classes, tables, fields, topology, and relationships in a database. It may be grown through time as the database is haphazardly assembled. It may be designed ahead of time to fulfill specific organizational needs. It can be downloaded, shared, and customized. You will create some database schema in this course. Here is an image of a database schema. Here's a blown-up view of a schema with a diagram key on the left and some specifics on the right. Creating datasets and also creating a database. This is done in Arc Catalog. On the left-hand side of the page, we see that somebody is creating a geodatabase. They right-click on a folder, which we will be doing, scrolling down to New and File Geodatabase. That is the type of geodatabase we'll be using. That's the method that we'll be using. You could do it in Arc Toolbox, but the method on the left is easier to do, and that's what we'll be doing for now. Once you have a geodatabase, you may import feature classes. You may do it via single or batch tools. You may use SQL to select a subset. The layer coordinate system will be automatically projected if different from a feature class dataset coordinate system. And here's the dialog that you'll be seeing quite often in this course. In this case, we're going to create a new feature class. In a geodatabase, somebody right-clicked, went to feature class, entered the name. You can import a coordinate system or choose a coordinate system, just like with shapefiles. They accepted the default X and Y tolerance and resolution. You may enter the fields as needed and then click Finish. Feature datasets contain related feature classes. Notice we created a feature class in the previous slide. This is a feature dataset. You also create that by right-clicking the geodatabase. This helps create, it must maintain a common coordinate system, and it may participate in topologic relationships and networks. And that's one of the many values of a feature dataset. And we'll learn about this more in this slide, in this presentation, as well as throughout the course. The coordinate system. Every feature class in a feature dataset must have the same coordinate system. The coordinate system is defined during the creation of the feature dataset. The imported or created feature class or the imported created feature classes will automatically be projected to the feature dataset coordinate system. And again, remember that feature classes are similar to shapefiles. Creating a feature dataset. You right-click on a geodatabase. You create a feature dataset. Name it. Choose the coordinate system. Choose a vertical coordinate system or leave it as none. And progress through the steps. Using geodatabase features. There are domains, split and merge policies, and subtypes, as I mentioned briefly at the beginning of this presentation. Let's move on to setting up domains. A domain, again, is a rule that determines the values that may be entered into an attribute. It's a rules for data entry. It prevents typing errors. It can verify that values fall into the correct range. It is created for the entire database. It can be reused in different feature classes. Again, there are two types of domains, a coded domain or a range domain. I already discussed these. This slide is actually a duplicate. Domain uses. It saves space by storing a numerical code, but set up domain for easy interpretation of the values. So we set up the code 12, 14, 16 to mean these items over here on the right. This is how we add a coded domain. We enter a domain name and description in an empty row. We set the domain type and field type, set the split and merge policies, which we'll discuss in a moment, enter the code and the matching description. Notice you must always enter the descriptions, even if they are identical to the code. Users only will see the description, so you must add the description. Adding a range domain. Enter the domain name and a description. Set the domain type and field type. Enter the minimum and maximum allowed values. Set the split and merge policies. And of course, you leave the coded values blank because this isn't a coded value domain. This is very important. Be sure to click Apply after each domain is entered. If you enter several domains before clicking Apply or OK, and one of the domains contains an error, it is very difficult to figure out which domain has the problem. You usually end up deleting them and starting over. Assigning domains. Domains are assigned to one or more fields. They may be assigned when the field is created or later. Domains must be assigned to fields of the same type. For example, a short integer field can't be used for a long integer domain, and a float field can't be used for a double domain. Assigning a domain to a field. This must be done in ArcCatalog. You highlight the field on the Property Fields tab, click in the Domain box, and select one of the available domains. Only domains of the same type will be listed. If a domain is not there, check the field types of the domain and the field. Because, in this example, this is a text field, so only text domains appear in this list. How domains work. Domains are most visible when editing. Coded domains, if the field in the table contents contains a drop-down box instead of allowing the user to type in data. This makes it a lot easier than having to worry about your data entry people entering the wrong information. Range domains do not warn you automatically when you enter a wrong value. There is no impact until you perform a validation. Records that fall outside the permitted range are then flagged for editing. Editing coded domains. A coded domain shows up as drop-down boxes when editing in tables or the attribute editor. The user selects the desired value. If you forgot to enter the description when you set up the domains, the values to choose from will appear blank, and that's why we must always include the description. And editing range domains. These you type in the values normally. Range domains do not automatically warn you if the entered domain value is out of range. You must perform a validation step on the selected features. Records outside of the range will be flagged for editing. And notice they're doing a validate features option up at the very top left. Split and merge policies. Split and merge policies. When polygons are split into pieces or merged together to make a single new polygon, the attributes must be updated. Depending on the type of attribute, different treatments are appropriate. For example, copy to the new one would be used for land use code. Leave it blank would be used for the parcel ID. Partition or sum based on the area would be used for a value. The split and merge policies control the behavior of a feature's attributes when the feature is merged or split. It saves the tedious re-entry of every attribute or prevents inappropriate assignments of data. I highly suggest you look up the split and merge policies definitions in the back of the GIS 311 textbook. In this case, we're looking at a merge policy, and the merge policies are to reduce the data entry tasks when features are changed. The options could be weighted average, sum, or default. If we were to merge these two stands, for example, the stand of forest on the left and the stand of forage on the right, to create a combined field or combined feature class, the crown cover percent would be a new value based on the area weighted average of original polygons. The board foot timber would be a sum from the original polygon, so all the board feet plus all the board feet. And the ownership would default to BHNF because that would be the owner of each of the stands. And a note up here, notice the merge policies are included in ArcGIS for consistency with other databases. However, they do not actually work in the editor. Instead, the user selects the feature that defines what the merged feature attributes will be. And so this is just an example of it. And in this case, the default for parcel ID, that would be left blank in this case because they're merging, so you're not exactly sure which it would be. The area is a sum. The default would resort back to R1, and the sum again would be these two items added to that item to sum to this value there. Split policies are similar, but it's because we're splitting them. If we were to take this rectangle forest stand and split it, the cover type would not change. It would just copy over the new value to the polygons. Because if this cover type was existing for the whole item, it obviously would be the same for the left and the right. The board feet of timber would be allocated to 2 polygons from the original area ratio of original polygon. This looks like about half, so it would be split in half. If it was 1/3 and 2/3, it would be split 1/3, 2/3. And the ownership in this case would default to BHNF. Split policies reduce data entry tasks when features are changed. And again, the choices are duplicate, geometry ratio, and default. Here we're showing a split policy where this parcel was split. The parcel ID stays the same for this at this point. The area is divided, so here it's duplicated. Of course, the parcel ID would have to be changed at some point by hand because it would get a new ID. Here we have 20,000. It was divided into an 8,000 and a 12,000. R1 was a duplicate, and down here it was a ratio of the land for the value. Moving on to subtypes. What are subtypes? Subtypes are different categories created for a feature class, with each category having its own symbol and default values. Integer-coded classes of features within a single feature class. Subtypes are based on a short integer field in the table that stores a numeric code. A description is added for display and interpretation and is what the user sees. Using default attributes. Automatically assign default values as features are added during editing or digitizing. This is an example where all new roads that were digitized would default to street or ST. The advantages of subtypes is each subtype can have its own default values. Each subtype is treated as a separate layer during editing. If you have an ArcEditor license or higher, which we do, then each subtype can have its own set of validation rules, domains, and connectivity. Each subtype can have its own topology rules as well. And remember, this is a good time for a refresher. We actually have ArcEditor, ArcInfo, which is higher than ArcEditor, and it is technically known as ArcGIS Desktop Advanced now. Subtype defaults. Different values can be specified for each subtype. This saves a lot of editing of attributes. Although there may be exceptions to the defaults, old subdivisions have lead sewer laterals, these can be edited if needed. Overall, editing is reduced. Each of the attribute fields may in turn have domains. And here we have during editing, each subtype is treated as a separate layer. When a feature is added, it automatically takes on the default values for its subtype. And this will make more sense when you're doing it in the exercise at the end of the chapter. When to use subtypes. When a feature class has a limited number of clearly delineated types. When setting different defaults for each type is useful. When the topological or network behavior of each type is different. Step 1. Plan the subtypes. The very first thing to do is plan. Establish the following priorities of the feature class. What subtypes will be used? Are they complete? Make a note of the attributes of the feature class, the domains that will be used, the split and merge policies for each attribute, and the default values for each subtype as applicable. In this case, subtypes for waterline feature class. The water main is the thicker line, the water lateral is the smaller. The sewer main is the tan, thicker object, and the lateral is the smaller object. Attributes and domains for waterlines. The attributes for the feature class may be pipe diameter, pipe material, the install date, and the max flow. Domains for the geodatabase for the diameter may be coded as 3, 4, 6, 8, 10, 12, 14, 8, 12, and 24. The material would be coded for those items, and the flow might be a range such as 0 to 2,000 gallons per minute. Step 2 would be to create the domains. Open the geodatabase properties, create the domains, and remember to click Apply after each one, so you don't have to go back and recreate it. Create the feature class. Use the Data Management Create Feature Class tool. Add the subtype field. The subtype field is a short integer field that will contain the code for each subtype. Created in the Fields tab of the Layers properties in ArcCatalog. We will call it line type. You would also add the other fields. Create the subtypes. Click on the Subtypes tab, choose the line type field you created as a subtype field, then enter a code and description for each of the subtypes. The different default values can be specified for each subtype. This saves a lot of editing of attributes. Although there may be exceptions, Overall, editing is reduced. Each of the attribute fields may in turn have domains. Set the defaults for each subtype. Click on a subtype to highlight it. Set the domain and default value for each attribute that needs one. You will need to know the default in terms of the actual stored value, not the description. You will now do some editing. Each subtype has its own template. Choose the desired feature to add. After the new features are added, they take on the default attributes of the subtype. And again, when you do this in the exercise, you will get a much better feel for it. And then you will notice all of the saved typing. Editing annotation. This is another valuable option in geodatabases. In Chapter 3, we learned to create annotation and we saved it in the map document. Now we will learn how to create and edit it in a geodatabase. So, of course, Chapter 3, that was in 3.11, we're now in 3.12, and we're going to learn how to create and edit it in a geodatabase. You would create dynamic labels. That's essentially what you're doing. You would use the symbol properties to set up the initial annotation, such as black Arial 8-point font. You would create feature annotation. You would scroll down, you right-click on layers, scroll down, convert labels to annotation. And we're choosing to store this in the geodatabase versus the map up here. And then you would convert. The initial results would look like this, or some sort of random output similar to that. You would then go in and use the Edit Annotation tool to select the annotation. Click the Roads Anno template, choose this construction tool, type the text in the annotation construction box, and place the annotation using the method appropriate to the construction tool. In the Edit Annotation tool, you use that to select, move, and delete the annotation. Annotation has handles with various functions. Click and drag on the handle to achieve the desired result. Notice the top one is to shrink and enlarge. This one down here is to rotate and rotate over here. And then this one is move. Again, doing it is a lot more fun than listening and looking at it like this. Annotation attributes. It's the same attributes window. We use this in Lab 5 from GIS 3.11. It has additional tabs for annotation. You set the font size, symbol, etc. The selected annotation appears in the window. Ways to create annotation. For horizontal annotation, click on the map once to place it. For straight annotation, click once to enter the anchor point and again to establish the angle of rotation. So it is still straight here, Sydney Drive, but we're making it angled. For a leader line annotation, such as Park Court, this leader line goes to point to it. Click once to place the far end of the pointer and again to define the near end and place the label. For follow feature annotation, which is very helpful, click on the feature that you're going to follow. For curved annotation, enter the start, mid, and end point of the curve. Making existing annotation follow a feature. This is a very eye-pleasing effect that you'll use on some final maps, hopefully throughout 3.12 and 4.12 and your final project. You'll select the annotation with the Edit Annotation tool. Right-click the feature to be used and choose Follow this feature right there. Click in on the center of the annotation and drag it around until the desired location is chosen. Click to place the text when you're satisfied. Stacking annotation for a better fit. Instead of Rapid City Regional Hospital, which takes up a long line, we're going to stack it to make it look like this. You select the annotation with the Edit Annotation tool, Right-click the annotation and choose Stack. It's a simple process. Right-click it again and choose Unstack to go back, or Stack again to stack more. In this case, it was stacked twice to make 3 lines. Some more annotation editing. There are many other techniques for editing annotation. This lesson was just to get you started. It's very basic material that we provided. Consult the help for more information. In addition, Esri Online has a plethora of options for annotation. I actually use quite a few advanced editing and annotation techniques in a final map that I produced very recently. I will show you that again when we start discussing the annotation. And this has been ArcGIS, Mastering ArcGIS by Maribeth Price. This was the 5th edition, Chapter 14 on geodatabases. Hopefully you've got an idea now of some of the benefits of geodatabases. It is now time to move on and start using geodatabases for the rest of your time in the GIS certification program. If you have any questions, feel free to email me or put up some discussion questions on the class website.